Over the past few years, 3D printers have become increasingly affordable. Prusa MK4, for example, is a great option that performs exceptionally well with precision tolerances of up to 0.3mm on the X and Y axes. However, more could be done here than simple 3D printing. Just like CNC machines, laser cutters, and art plotters, 3D printers also talk in G-code. So basically, 3D printers are part of the same family, just with an extra axis. At the end of the day, they all love and speak the same G-code language. So I started my search for existing solutions, and I quickly stumbled upon this pen plotter attachment on printables. All credits to the owner of this design. This is how I got the hardware part of this project figured out. I printed these with PLA and simply glued the mount and the railing together with superglue. Screws seemed excessive and I had no M3 screws laying around anyways. The railing glides smoothly and the printed spring keeps the pen down. The PLA might not hold on this one, so rubber bands are the better option in the long run. I sanded down the area that grips onto the fan to make it easier to remove and put on. The default tolerances were too tight for me. I then attached the pens to the 3D print with screws, and this is how the entire thing assembles together. This is where the fun stopped, as I now needed to find a tool that allows me to use this printer as an art plotter instead. Unfortunately, I could not find any solution that could do this for me. I tried some SVG-to-G-code tools people had built, but they were finicky and required a lot of trial and error before I could get a usable print. So I turned to VS Code and ChatGPT to make one myself. I started with a React plus TypeScript setup. The idea was simple. The input would be a SVG file and the output would be G-code. But first, we need to understand why SVGs. Unlike pixel images like PNGs or JPEGs, SVGs are made of math. Points, lines, and curves defined by coordinates. That means no blurriness, no resolution limits, and most importantly, perfect precision for plotting. So you drop in an SVG file, the tool parses it in the browser, it then samples curves along each shape's path, basically turning smooth vectors into polylines. It also detects colors per shape and groups them into layers, so you can pick exactly which color to preview and export. There's also a quality slider to control sampling density to balance between speed and quality. There's also a canvas that draws the page area, the safe zone, and then renders the selected polylines. This makes it extremely easy to position the print accurately on the paper, and you can see exactly how the pen will move. Finally, it generates G-code, handling drawing speeds, Z-moves, and optional pauses for changing pens. I was finally ready for my first plot. I decided to go with Crayola markers, which sort of became an issue later on. I printed multiple pen mounts for a quick and easy swapping of colors between prints. I attached the paper onto the print bed using some clips I found in a drawer. I clamped at the rear side of the bed so it does not interfere with the side pillars. The margins need to be measured on all sides to be put into the software so we can identify a safe printable area and to ensure it does not go over the edges. Without these margins, the print head would collide with the corners of the paper. I then put the pen on without the spring and manually lowered the Z-axis until the pen rested comfortably on the paper. It should not be forced down or barely touched to ensure a consistent print. I then write down the height of the Z-axis into the software so it knows the correct height of the pen. After plugging in all these parameters into the tool, the preview helps to position the print and debug any movement easily. Finally, we can download the G-code and plug the USB into the printer. The software adds G28 to the start of each file, which is Prusa's command for homing. This calibrates all the axes before each print. After calibrating, the printer pauses for us to put the pen on. Everything seemed to be working fine, but I soon realized that this marker might not be the right choice for this job. Honestly, it was nice seeing the thick markers in action, and it gave me a lot of ideas of how that could be used in a future print. So I stopped the print and flipped the paper for a fresh start. I removed the marker and decided to go with the fine tip pen instead. I then restarted the job with the same G-code file. This took around 10 minutes and I was kind of impressed with how it turned out. The accuracy and detail is remarkable and I was satisfied. Now I knew the software worked, so I wanted to try something more complex. But I soon realized that I cannot keep relying on Google Images and I had to create something from scratch. Luckily, I knew a thing or two about P5, so I decided to give it a go. I initially tried making vector art in Illustrator and Inkscape, but for some reason the printer never liked the files exported from those two softwares. I also didn't know what I was doing with those softwares, so maybe I was the problem. Anyways, I knew I wanted to try multicolor printing this time. I had this idea of converting a regular image into strokes, with each color having different angles. This would be an interesting experiment as different angles of strokes will create hatching and replicate the fills and shades of the original image. With the main idea in mind, I started coding, and after a couple hours of debugging and almost entirely given up, I ended up with something that I was happy with. Things were looking good, but my software was not detecting any colors in the SVG file. This was odd, as it was detecting color in any other image I would upload. I could not just trash this code I worked so much on, so I had this brilliant idea of moving the color separation process one step back. Basically, I exported separate SVG files for each individual color and uploaded them one by one. This worked perfectly, and I could finally print in color now. You could theoretically print with as many colors as you want, but for this one I went with 5 colors only. With a higher number you can achieve more detail, but with the cost of time. The print took about 2.5 hours. After each color pass, I just slide in the next pen and load the matching G-code file. The software handled everything smoothly, and honestly the whole process felt surprisingly seamless. The printer was kind of loud, but that steady mechanical rhythm gave the whole thing this analog feel, like an old plotter or typewriter just doing its job. Regardless, I'm happy with how this turned out and I can't wait to try new designs. This project would not exist without the open source creators who share their work online. The pen mount, P5JS, even parts of the code, it's all built on shared curiosity. And sure, this isn't practical. A 3D printer pretending to be a 2D one doesn't make any sense, and is low-key stupid. But that's exactly why it matters. The printer has limits. It cannot draw everything. It does not understand beauty or color or balance. But when you work within those limits, when you design for the machine instead of against it, something happens. Everything I worked on will eventually be made public. If you want to try it, build on it, or just mess around, let me know in the comments below. Let me know what you think.